Welcome back, mathematicians. In this video, we are going to learn about the inverse trig function. Now, a quick reminder, in order for a function to have an inverse function, it must be one-to-one. We can see based on this graph that our cosine function is not one-to-one because it fails the horizontal line test. As a result, what we do is restrict the domain from 0 to pi inclusive, meaning we are including the endpoints of 0, 1 and pi, -1, which then if you look at that section of the graph, it becomes one-to-one. The range, however, will remain the same, which is going to be -1 to 1 inclusive. This then gives us the definition of our inverse cosine function, which is that y is equal to the inverse cosine of x, if and only if x is equal to cosine of y, where x is between -1 and 1 inclusive, and y is between 0 and pi inclusive. Let's now use that information to find the exact value of each of these inverse cosine functions. We're going to start by letting these inverse cosine functions equal a variable, and I'm choosing theta to remind myself that the output of these inverse cosine functions should be an angle, whereas the input of these inverse cosine functions are the ratios. I'm then going to take the cosine of both sides, and so what I get is cosine of angle theta is equal to -1/2. So what I'm being asked to find is the angle when evaluated for cosine that equals -1/2. It's important to remember that theta is restricted from 0 to pi inclusive, meaning that we can only look at quadrant 1 or quadrant 2 on the coordinate plane or on our unit circle. Now at this point you could use the unit circle to figure this out. I'm going to go ahead and draw myself a picture on the coordinate plane. I recognize that the initial side of my angle will be on the positive x-axis. Because cosine is equal to a negative ratio, I know that the terminal side will be in quadrant number 2. So again, you would use your unit circle to figure out where in quadrant number 2 would you have an x-coordinate that's equal to -1/2, and then that angle would be your answer. I, however, am going to draw myself a quick picture. I know that the adjacent side is -1, hypotenuse or radius is equal to 2, and the opposite side is square root of 3. This then gives me my reference angle, which is equal to pi over 3. I then need to come up with this angle here, which is my angle theta, and so theta is equal to 2 pi over 3, and that is the solution. Let's now go to inverse cosine of square root of 3 over 2. And again, I'm going to set this equal to theta. I will then take the cosine of both sides, so I will have cosine of angle theta is equal to the positive square root of 3 over 2. Because it is positive, I know that the terminal side will be located in quadrant number 1. And again, you could use your unit circle to then find in quadrant number 1 the x-coordinate that has a value of square root of 3 over 2, and that associated angle will be your answer. I will go ahead and draw myself a quick picture in case you are not using a unit circle. The adjacent side will be square root of 3. The hypotenuse is 2, which means the opposite side is going to be a value of 1. This means this angle is going to be pi over 6. And there's your answer. So inverse cosine of square root of 3 over 2 is equal to pi over 6. All right, guys, good luck.